So today we are going to solve the NCERT textbook. This is NCERT textbook and this is the first chapter, relation function, exercise 1.1. Okay. Okay, before that you should uh, look into the examples, all the examples given here, all the examples and their solution, how to solve it. I gave you this example, this perpendicular lines. There is also another example of triangles. Okay, so there will be more examples, and this is the equivalence relation, definition of equivalence relation. Okay, so in the exercise, question number 1, generally I left it as exercise to do yourself, and then from 2 we will do it, and before that you should try this as an exercise. As it is exercise, you should try it on your own. If you cannot do, then I will try to solve it. So now try to solve the question number 2 to 5, and if you have any problem in question number 1, tell me, I will solve them. Okay. Okay, so I am giving some time to do these exercises. Take your time and solve it. So Prantika, you have done this problem number 2. This was the relation a is less than b square, right? R such that a comma b, a is less than equal to b square, and the set was real number, set of real number r. Then you have written that a comma a belongs to r, then a is less than a square, which is false. R is not reflexive. But there is a this is a vague statement. uh, I mean, for which a is less than a square, some in real number there are some a belongs to real number for which a is less than a square, and there is some a such that a is less greater than a square. So you have to find out that those a's for which a is greater than a square, then you can say that this relation is false. Are you listening? Hello, response.
Yes, yes, yes,
Pratiti.
Yes.
So uh, there is some x for which a is less than a square. I mean, for a greater than 1, a square, I mean greater than equal to 1 also, a is less than a square. This is true. But a less than 1 and greater than 0. For this a greater than 0 and less than 1. For these a's, a square is less than a, less than or equal to a. ठीक? Okay. So
okay,
there is an x. So there is an x. You should write let a less than 1 and greater than 0. For this, a square is less than equal to a. That means not for all a, not for all a belongs to real number, a comma a belongs to the relation r. That means r is not reflexive. Okay. Now for the symmetric part, you have to assume a comma b is belongs to r. That means a is less than b square. This was the definition, right? A is less than b square. From here you cannot say that b is less than b will not be less than a square. You cannot say that. There are some examples like this. I am taking some examples which a b are real number, of course. There are some real number like this. 2, let us take a equal to 2 and b equal to 3. Let us check this. So okay, this does not imply, uh, may or may not implies that b is less than a square. I mean, b can be greater than a square. Let us take some example. Okay, for this example, b, that is 3 square, which is 9. 9 is greater than 2, and uh, b, which is 3, is less than a square, that means 4. For this example, a comma b belongs to r implies b comma a belongs to r. Okay, for this example, but we have to give an counter example so that a comma b belongs to r but b comma a does not belongs to r. That means a is less than b square but b is greater than a square. We have to show this. Let us take some example. B, a is less than b square. Okay, b is greater than a square. Let us take a equal to 3 and b equal to 10. Okay, a equal to 3, which is less than 100 square, 10 square, that is 100, and b is greater than a square, which is 3 square equal to 9. B is greater than 9, 10 is greater than 9. So that means for this relation, I'm writing in the left hand side. For this relation, let us take, I'm just explaining to you, and then what you have to write like this. Let us assume a equal to 3 and b equal to 10. For this, 3 comma 10 belongs to r but 10 comma 3 does not belongs to r. That implies r is not symmetric. In the reflexive part, we have already found that for uh, for the real numbers which is greater than 0 and less than 1, a comma a does not belongs to r. That means there are some elements in r for which a comma a does not belongs to r. That means the for all a belongs to r, it is not true. That means it is not reflexive. And we have already and next we have found that an element 3 comma 10 which is belongs to r but 10 comma 3 does not belongs to r. One example is enough to um, to show that this relation is not symmetric. Again, for transitiveness is uh, also tricky. We have to find out more examples to do this like this. Say a comma b belongs to r and b comma c belongs to r. That means a comma c has to belong in r. That means this means that a is less than b square and this means that b is less than c square. This may not imply that a is less than C square. There is an example. Okay, take A equal to some 9, B equal to 5, and C equal to 3. I hope this example will make it. Mm, So A is less than 25, which is B square, and 5 is less than 3 square, which is C square, equal to 9. Both works. Okay, sorry. Uh, so here it is 9 is less than equal to 9. It works. But okay, let us take 10. It will do our job. Okay, so 10 equal to A, which is less than 25, and 25 is B square, 5 square. Next, 5 is less than 3 square, C is 3, and it is 9. And A is not less than C square. A, which is equal to 10, this is not less than C square, which is 9. So again we have another example. So this example, to show that this relation is not a transitive relation, we found a pair of A, B and BC. So which are the AB? AB is 10 comma 5. This belongs to R. And 5 comma 3, this belongs to R. But 10 comma 3 does not belongs to R. That implies R is not transitive. Okay. So here
Okay.
this relation is not a reflexive one or symmetric one and transitive one. Nothing. So we gave some examples or counter examples, rather say. These are the counter examples that violate the the conditions that makes a relation reflexive, symmetric and transitive. Okay. Next, Praditi, why did you uh, didn't do this problem number 2?
Number 2, I'm not able to solve it.
Okay, okay.
Number 2 and number 5 also.
I
Both
also
are same almost.
okay. And Prantika, number 3 is also incorrect because not incorrect. It is same. The you have said about these vague things here. B equal when B equal to A equal to A plus 1, which is false. Not like this. You have to say something with logic or some mathematical logic. Okay, but uh, Protiti has done nicely. So here this is a finite set. So you can write the relation itself when R is equal to A comma B such that B equal to A plus 1. So the set is this. So 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5 and 5 comma 6. These are the relation. So for all A belongs to capital A, 1 2 3 4 5 6, 1 comma 1, 2 comma 2, none of these elements belongs to R. So this is not reflexive. For not reflexive or not being reflexive, one is enough. One element uh, one element of these, any of these elements does not belongs to R. That would enough to not say that R is not reflexive. And 1 comma 2 is in the set relation 1 comma 2, but 2 comma is 1 is not in the relation, so it is not also symmetric. And next, 1 comma 2 and 2 comma 3 is there. Here it is 1 comma 2 and it is 2 comma 3, but 1 comma 3 is not in R, so it is not transitive. Okay, Prantika, did you understand this?
Yes.
Okay, so R is not reflexive, symmetric, and transitive also. This is right. And 4 is A is less than equal to B. Which was the parent set for this relation? Okay, I'm checking. Question number 4. Show that the relation R in the set of real numbers. Again, AB such that A is less than equal to B is reflexive, transitive, but not symmetric. Okay. So it is symmetric. I mean, you have to take so so what I have written. Like I'm showing how to write C. So you have to write this R is equal to A comma B such that A is less than equal to B, and here you have to write A comma B belongs to R because the set is defined on the set of real numbers. So A belongs to R. A comma A belongs to only R. I mean relation R because A is less than A. A less than equal to A. So A comma A belongs to R. Okay, we should write this. এখানে here you can also write for all A belongs to R. A is less than equal to A. That means A comma A belongs to the relation R, and hence R is reflexive. Okay, now for symmetricness, 2 comma 4 belongs to R because 2 is less than 4, less than or equal to 4, but 4 comma 2 does not belongs to R as 4 is greater than 2, so R is not symmetric. And before that you can mention that 2 comma 4 belongs to R. We are taking two elements which are real number, and for these two elements 2 comma R belongs to R, but 4 comma 2 does not belongs to relation R, and it is not symmetric. And okay, what we have to told, mm, reflexive and transitive but not symmetric. Okay, okay. So for this, if AB and BC belongs to R, you have to write here explicitly that AB belongs to R and BC belongs to R. So before that you have to write A A A comma B comma C belongs to real numbers. These three are real numbers. If AB belongs to R and BC belongs to R, then A less than equal to B, and uh, this is not correct. A less than equal to B and B less than equal to C. What you have written? B is greater than equal to C. So from these two, A less than equal to B and B less than equal to C, this implies that A less than equal to C. Okay, I mean this, when ABC are equal, A equal to B equal to C, then this equal sign is there. I mean for that condition only A is less than equal to C. Otherwise, if A is less than B and B is less than equal to C, then A is less than C, strictly less than C. Only equal when both ABC are equal. So that means AC belongs to A comma C belongs to R, hence R is transitive. Here R is reflexive and transitive but not symmetric. right? Okay. Next, number 6. Okay, 5 you have skipped. Show that the relation R in the set 1 comma 2 comma 3 given by 1 comma 2 2 comma 1 is symmetric but neither reflexive nor transitive. Okay, R is, let A equal to A 1 comma 2 comma 3. Okay, and R is 1 comma 2 2 comma 1. So it is clear that R is symmetric because A comma B and B comma A is in R. But A 1 comma 1 2 comma 2 3 comma 3, none of these belongs to R. That means R is not reflexive. And since 1 comma 2 belongs to R and 2 comma 1 belongs to R is symmetric. Okay, and here also you does not have to write this if. You can write, this is a wrong notation. 1 comma 2 belongs to R and 2 comma 1 belongs to R, but 1 comma 1 does not belongs to R. So R is not transitive. Therefore R is not transitive. Okay, here R is only symmetric. Okay,
Okay.
so Praditi, you got your mistakes.
Yes.
Yes, so this is how you have to write in, I mean, to solve these relations question. So there are a lot of question in NCERT. First, do all these 16 problems. Then again, this is your homework for this week. And next class, we will learn about types of functions. Okay, this is one function, many one function, and onto function and bijection. All of this. Okay.
Okay.
Okay.